Now it's time to do word problems with proportions. These might actually be easier than the other things we've done, especially since you get to use a calculator! Hooray. So the key thing with proportions is that you have to match things up correctly. So here's this example. Right now, as of this morning, Mark Trumbo of the Arizona Diamondbacks has been up to bat 35 times and has hit 5 home runs. Okay? That's what the statistics said. I'm just writing it down. So, at this current pace, how many at-bats would he need to hit 23 home runs? Now, it doesn't matter how you want to set up this proportion. What does matter is that you keep the ratios and you keep the rates the same as you go across. So you may say, do this. I want to set it up so that I have home runs to at-bats. Okay? So if you set it up this way, when it comes to your fractions, just like we've talked about with ratios and rates before, you would have it set up like this. Home runs to at-bats. Okay? But the thing is, you have to make sure that it's still the same as you go across. So home runs to at-bats must equal home runs to at-bats. It's got to be the same setup here. If you flip the fraction over, it won't work. So one of the situations that we have here is that he has 5 home runs and he's been up to bat 35 times. So how could you write that as a fraction based on the setup that I'm writing right here? Home runs to at-bats is what?
5 over 35.
It's 5 to 35, right? On the other side here, we're going to draw our fraction bar. Do we know the home runs or at-bats for the other part of the question?
So how many at-bats?
What do we know? What number do we know? How many at-bats or how many home runs? What does the last sentence say?
23 home runs.
So that means 23 home runs. That's this number right here, right? And the question wants to know, let me read this, how many at-bats? That means that's the part we don't know. And that's the part that you will represent with a variable, say something like x. Okay? 5 home runs when he's at bat 35 times, 23 home runs when he's at bat, I don't know how many times. That's what the question is asking. How many? And this is, when we see things like this, this goes back to what we talked about last week. If you take data from a sample, can you extrapolate that to see at this current pace, at this same rate, what would it be? Okay. Now, when we did these before, we said the cross products were equal. When you have a proportion, that means the product across, bless you, this way, bless you, 5 times x should equal the product going across the other way, which is 35 times 23. Okay? So, I mean, you can deal with large numbers if you want to. You can actually reduce this one. This is going to be a nice, fairly nice number to work with. But since we do have calculators, let's go ahead and do this. That means 5x is equal to, what's 35 times 23? 805, you sure? All right. How do I solve the equation 5x equals 805?
Divide by 5.
Divide both sides by 5. And this tells me that x should equal what?
161.
161. Okay. So the question was, how many at-bats would he need to hit 23 home runs? Okay, and we can state that, make a sentence here. So at this pace, whoops. At this pace, he would need 161 at-bats, in order to hit 23 home runs. Okay. Again, this is not something that we could exactly predict will happen, but if this pace stays up, that's what it would be. That's how many times he would need to step up to the plate to hit that many home runs. Okay. Again, this is still fairly early on in the season, and player statistics vary wildly in the first few weeks and months of this season because the sample size is so small.